service to the association, which was very well deserved. Hazel says she is not a professional astronomer by any means, but an enthusiastic amateur, and too a busy one. So it's my pleasure to invite Hazel to tell us about the beauty and the violence of the sun, and I believe with some quite stunning videos. Thank you. Thanks, Hazel.
Okay, this is the first time I've done this talk to such an active group, so I'm sure some of you will know more than me. So to start with, I'm going to just run through a few of the physical effects, like
Hazel,
seasons.
Would you like the lights out?
Yeah, probably a good idea, thank you. Okay, so we have seasons, and this in effect is an effect of the sun, because the orbit that the Earth is in and the position of it will affect the amount of sunlight and the heat that we get from the sun. There are another effect of the sunlight hitting or passing through raindrops, and I'm sure that there isn't anybody in the room who hasn't seen one. If you haven't, then I'm very sad. Sun rays, again, it's something that most people take for granted. They're there, they happen, but again, it's an effect of the sun. It's the sunlight streaming through and being caught, the photons of light being caught in the sort of dust or pollutant or moisture that's in the atmosphere. Sundogs. Now, when I first got really into this, I thought, I've never seen a sundog. Really want to try and see one. And I was on the train coming back from a BAA meeting, and I looked out the window, and there they were. And I had to really hold onto the table and think, no, I daren't get up and start saying to everybody, look, there's sundogs there, because I think they would have had the men in the white suits when they got to York. But anyway, I have now seen sundogs, and I've seen them quite a number of times since, because I now know what to look for. And has everybody here seen them? Yes? How about sun pillars? Yeah? Now that's something I've probably seen but not registered, and now because I want to see one, I haven't immediately.
You move up here, you're much more likely to see them.
Probably, yeah. Halos around the sun. Again, it's an effect because it's to do with the sunlight hitting the atmosphere and crystals or water vapour or other pollutants in the atmosphere. And you also get moon halos as well, which are particularly noticeable if it's slightly misty or slightly foggy, much more noticeable than. Okay, now this is something I'm not going to talk about very much because there's too many of you that know far more about this than me. You've got the sun at 6 degrees or less below the horizon coming up and hitting these very, very high clouds and reflecting back down to the Earth. I have seen a number of them. I'm not really sure that I've seen them properly this year, but just the way it goes. As I say, that's how they form, but I'm sure, as I say, you already know about that. But again, it's an effect of the sunlight hitting things like clouds or whatever within our atmosphere or around our Earth. And there's some pictures that I've picked up off the website, some from BAA people and some from just general NASA and other places. And to a degree, they are affected by how the polar, the jet stream is around the poles and pulling in cold air, ice crystals and such like that are in the upper atmosphere. Now, this is, how many of you have seen these? Yeah, everybody. Well, just after we moved to York, having moved up from London, we moved up in September, and in February I happened to look out and saw these, and I went and knocked on my neighbours' doors. God knows what they must have thought. Because I've never seen them before, but it made the news. It was on the 6 o'clock news, the local news, and the fact that I'd actually seen them with my own eyes, and got a number of neighbours to see them as well. I thought it was really incredible. And again, they are formed like the NCL clouds, and same sort of aspect. But these you only see in sort of the winter months, whereas the others you see in the summer months. Okay, we're coming on to eclipses now, and I'm sure that most people are aware of eclipses. You may have seen a full total eclipse or only a partial eclipse. I've actually seen two. One I went down to, the one in 1999 to Plymouth. I'm glad I did, because I saw the effects, the sun, the shadow of the going across the clouds, and how fast it moved. That stayed with me all this time, because it just was so fast. You just don't expect it to move that quickly, but it did. The drop in temperature, the drop in light, the effect on the wildlife and things. And it was really an emotional time, because as it came out of eclipse, the whole of the Plymouth home was full of people. And you could tell the awe that there was, because there was this sort of silence and hushed whispers of people afterwards. And a lot of people had tears in their eyes, because it was something so incredible that you wouldn't normally get a chance to see. And then, of course, I went to Turkey and saw a perfect one, and saw some of these. I saw the wedding ring, no, the engagement ring, the partial eclipse, the baby's beads, and totality with some of these aren't my photos or even anybody I know, they just came off of the NASA and the Soho sites. Some of the prominences that you only get to see during a total eclipse. And of course we have eclipses at solar minimum and solar maximum, where at minimum you've got quite an intense but not very wide corona, but during maximum it goes out thousands and thousands and thousands of miles from the sun. And again, that's an effect. And I'm sure that many of you know about Dennis Vininsky, and I hate him because he can get such wonderful shots from the back garden. But when we were in Turkey, again, this is another effect. Whoa! I pressed the wrong one, sorry about this. Hate technology. Right, okay. So, I went with a number of people from the York Society, and somebody had a sheet of paper with lots of holes in it, so you could get that effect. We looked through where there was a tree, and you can see all the hundreds and hundreds, the way the light was diffused through the branches and things, so that you can actually catch it. And again, it's an effect. Okay, it's only an optical effect, but it's still an effect of the sun, which you wouldn't get if we didn't have the sun. And that was in the last few seconds before totality, the light bands. Unfortunately, we couldn't get a really decent photo of it, but that was... Sorry?
You can still see it.
Yeah, you can still see it. It was much better to see it with your own vision than it was to try and capture it on there. If you'd had... I've seen somebody who'd had a video of it, and you can see it because it's rippling, and that was quite phenomenal. And again, it's an effect. Okay, one of our people, or two of our people, now I'm not sure if this is going to work, so I might need you to press the button. This is to get this to work. How do I get a...
Just click on it.
Yeah.
No. I've done something wrong now. It's not going to work. I'm going to have to do something. There we go. This is an annular eclipse, it's not a total eclipse. And an annular eclipse is where the sun and moon are in perfect alignment. So therefore you get that little ring around it. Doesn't happen as often as total eclipses or partial eclipses, so I'm told. I've not seen one, but has anybody else here seen an annular?
Yeah.
Oh, quite a number of you. So you can be aware. Did the light drop as intensely as it would have done So you still get a reasonable
It
amount
was
of
still, yeah, it was still quite a big drop in light level,
Yeah.
as I recall. That was what was that name? That was the one where everybody went up to.
2003.
2003
Yeah,
was, that's right.
Yeah.
And Patrick Moore went, we all came up to the north of Scotland because you could see it from the north of Scotland, and Patrick Moore went away somewhere where it was completely clouded out. And we were on the east coast and it was beautiful.
Yeah. So anyway, so that's an annular eclipse, not a total eclipse, but again, it's still an eclipse. Now we come on to lunar eclipses, and lunar eclipses are much more common, either in full or partial, because of the fact that the Earth and the Moon are in the different positions. Rather than the Moon blocking out the Sun, it's the Earth. Now the wonderful thing about lunar eclipses is that you never know what colour the eclipse is going to be. It's a lot to do with the amount of gunk in the upper atmosphere. So again, it's an effect of the Sun, because the sunlight streams through, it hits the atmosphere on the Earth and is bent round so that the Moon is in total shadow or partial shadow. When it's in the total shadow, it can be anything from a very pale lemon to an incredibly deep, dark, blood red brown moon. There was one a few years back and it was very foggy in York, and I followed it through from quite a late partial stage, and I was tracking it, and it's as well I did, because in totality you couldn't see it at all. It was completely dark, and it was an experience. So I've seen it in various different stages, different colours, as I'm sure most of you have. Is there anybody here who hasn't seen the lunar eclipse? Good. And again, as I say, that is an effect. And that's just an example of the stages that it goes through in much the same way as partial eclipses with the Sun. And when it's in the umbra, it, as I say, it can be anything from that sort of pale colour or lighter to something much darker than that. And of course, another effect of the Sun is we get lots of photons and radiation. So anybody out in space, doing spacewalks on the space station or whatever, when there's a CME that comes from the Sun, they need to be aware they have to be in protective suits. And of course, even if there isn't, they still need to be protected, because the sunlight is so strong. If they haven't got super protective visors, they'd be blinded in an instant. Okay, so those are the basic sort of run of effects. So I'm going to go on to physics, and I'm not an expert, I'm not a professor of study of this, so this is just general sort of science. Our Sun, like any other star, is born in what they call the pillars of creation, these great soup of particles of dust, of other matter that's out there in the universe. And these are tiny baby stars that are just being born, in effect, and all the young ones around. And how this happens is that there's an event that happens somewhere out in the universe. It causes a wave, or gravity wave if you want to call it that, or just a general blow of wind that will knock into these, and when it does, it forces a number of this mass to sort of clump together a bit more, and as the masses get bigger, the gravity starts getting involved, pulling in more matter until it gets to the critical stage, and it bursts into life. And here's an example of the Hubble telescope of a there's a star in there with a solar system forming around it, and other ones in different phases. So this is all happening within the area of mass. Our Sun is about halfway through its life. We've got these are billions of years, by the way, as it says there. So we've got quite a long time to worry about. I don't think it's going to affect us particularly. we had this discussion over dinner. Really, will anybody be around to witness this or even be bothered with it? Anyway, our sun, biggest object of our solar system, it is a huge hydrogen bomb, if you want to put it that way. Nuclear mass, nuclear fusion going on. It's made up of varying layers. Whoops, wrong way. You've got a core right through to the chromosphere around here, prominences, sunspots, radiative zone, conductive zones, etc. So in a way it's a bit like planets where you've got the Earth with the crust and the mantle and the lava and such, but it's in a huge form in comparison. As I said, our sun is just mid-range, nothing very exciting, very boring really, it's just middle range, orange, yellow star, main sequence. Nothing spectacular as the whole picture goes, however to us it is essential because without it we wouldn't be here. So the sun, when you look at it, has these areas. These are active regions. You've got positive, which is the white, and negative regions, and you very rarely get any. These are too tiny to pick up, but usually you get a negative and a positive whenever you've got any active regions. So you can see it quite clearly there. Another video. Okay, so why do we get sunspots and active regions and all the rest of it? As you know, the sun has all these bands of magnetic bands around it from the North Pole to the South Pole, which keep it all nice and tidy and neat and all the rest of it. And any of you that have seen balls of wool, which are beautifully round, that's fine, but as soon as you start pulling anything out, it causes problems. Now the sun rotates at different rates at the poles to the centre, and it's because of that that you get this winding up effect. So imagine a ball which has got elastic bands around it, and you can twist the centre while the ends are stuck, and you'll get to the stage where those elastic bands get so taut they sort of ping off, and that's what's happened here. So the sun is made up with all these granules, and these are each granule is over 100 kilometres wide. So you've got masses and masses and masses and masses of them, and that's a sunspot, which I'll get onto in a minute. I'm sure that all of you at some stage or the other have seen jam being made, and you know that boiling roll where you've got the hot sugary consistency coming up from the bottom of the pan where it's got really hot, coming up to the top and then falling back down, and that's exactly what happens here. You've got the very hot plasma coming up to the top of the column, and then it will fall back down again, and that's going on. That's only a tiny fraction of the sun's surface, and you can see the number of those, and the whole sun is covered with those. So here we are looking at it from a bit further back, and you've got these dark areas which we call filaments, and that's where you have a prominence rather than it being edge on. It's actually happening across the surface of the sun, and that because they have risen up from the surface, they're a little bit cooler, and therefore it looks darker. So that's why we can see them. Whereas when they are edge on, you can see them in their beautiful, stunning, sort of glorified, lacy, whatever type of bit. There might just be streams like that, or as we call them, like hedges there, or these incredible eruptive prominences here. And just to give you some idea of, sort of put things into perspective, this was taken off the Soho site, and this is to scale. So there's the Earth, approximately, and you can imagine how many Earths would fit into that one prominence. Are you able to try and nudge it for me?
Magic.
Just, no.
No.
Right, if you just...
Oh, right,
Oh,
yeah.
there we go. Right, this is a prominence that's coming off. Did that happen?
Yeah.
Yes.
Oh, right, that happened so quickly. Do you want to see it again?
Yes.
Yeah?
Is that your press?
No, there's the... No, this at the front.
Maybe to step back. I'll do it again when it's done.
Right, okay, so you see how they do it, they come quite quickly and then suddenly they're wham out there and just little ones to ginormous ones, and they stream out thousands and thousands of miles from the sun's surface. Just absolutely phenomenal. Okay, I mentioned about sunspots. So here you have the umbra, which is the area around, and the penumbra. Now, if you think of those prominences, they are actually loops of plasma coming out on a magnetic loop, coming from positive end to a negative end, and they're streaming up and over. And that's basically what is happening here. So you've got it, one coming out from here, and it's going right over to somewhere in here. And they're all doing it all around there. So there's lots and lots and lots and lots and lots of streams going up and back down into the hole, otherwise known as the umbra. You get light loops or light bridges, and that's where you can actually see one of these magnetic loops going across with all that supercharged plasma going across it from one side to the other. And there's one actually going into the negative area. Okay, got another one there. Right, this is a formation of a sunspot. Now, if you look at the surface, those sunspots are relatively small, but you can see that area underneath showing that incredible how it is. It's a bit like an iceberg. You see a tip, but you don't see what's below, and that's what's happening with sunspots. And another one, please. Okay, this is, just watch this sunspot here, how it changes and moves over a relatively short space. This was a number of days. You see how it forms, it moves. You've got all these bits that break off and move, and others that get bigger and smaller and so on. So it's very dynamic. It really happens relatively quickly. I was talking earlier and saying that when I first really got into doing solar observing, I'd go out in the morning, I'd go out lunchtime, I'd go out when I got home from work, and again later in the day if it was a clear night, you know, and the sun was in a position where I could do it. And I'd end up with 4 recordings, and I was thinking, okay, so which one do I now submit? Because you can't submit 4, you only can submit 1 a day. But it was interesting to see how that changed in some cases. Sometimes it didn't change at all, and in another occasion they can change quite rapidly in a matter of hours. We have the classifications for different types of sunspots, from a simple pour, which is really quite a tiny one. Sometimes they're only there for a few hours. Others will develop into a much more significant size over a period of time, through to what we classify as a quite complicated group structure. Some of them get really, really huge and the naked eye visible from Earth. This was taken over a couple of days, and you can see how that there to how it is there, and that's virtually split into 2 at that stage. And then of course we have what we classify as the butterfly diagram. And people say, oh, well, when you look at that, we didn't have that many sunspots on the sun, but by then we've got lots and lots. There's a number of reasons for that, mainly because we've got a lot more people doing observing. We have better equipment, so therefore we're able to record things a lot better. But it doesn't mean to say that there isn't some truth with the minimums and maximums, because again you can see how the minimum and maximums are all up and down, all along, and you get some which are very high and some which are very low. Our current cycle, we are around here. We don't quite know when solar minimum is actually, or which point solar minimum is going to be, but it looks like it's going to be quite a low one. That's what they're predicting. That's what they would anticipate as being on average. So it looks like it's going to be a really deep one again. And again, trends. People think, well, this is unusual if we've got a really bad low cycle. But in fact, when you look at the trends, you get peaks and troughs, and then you get some really big troughs and some low troughs and high peaks. Seems to be almost cyclic the way it goes. Not in the same way as you know that there's an 11-year cycle and you know that you're going to get minimum and you know you're going to get maximum. But it's over a period of time. As sun at the end of the day is a variable star, and all variable stars do follow some form of pattern as they age over time. These were taken by Lynn, who is the BAA section director, and these were taken in 2003 when we were looking at all those sunspots when there was all that major activity. So where we are in the cycle, that was the last minimum then, and we are anticipating that we are almost there now. But you can see how it goes from sort of quite a darkish colour through to really quite bright with lots and lots of activity on it. So that's the way it goes throughout its cycles. Okay, so that image from Lynn coincides with this. There was some huge activity, really huge sunspot groups on the sun at the time, and you can see all the activity there. No, I'm afraid I've got a number of videos now. So this was taken showing the coronal mass ejection, and watch that area there, how it's just spewing stuff out umpteen times. It didn't just happen once. It just kept on and on and on, and it just happened to be in the right position, so it was heading straight at us. It made the news because it produced auroras that were seen far down into Europe. And I actually had a telescope out in the village at the library so people would see the sunspots that were producing it. Because it had been on the news, there was a lot more interest. So it was actually quite useful.
Well, that's something Carrington would have seen.
Yeah, exactly. Can you do it again for me?
We have
Right, this is in another wavelength. Now just watch how these streams are coming out and see all these bits, which is the charged plasma hitting the satellite. It just went on over a period of time, just kept on and on. And you'll see shortly where it gets really bad. Here we go. Much more of a snowstorm there, but we've got worse to come. There you go. Those were the two that caused the major auroras that happened.
Yes, it's over.
And then it happened again. And it was all from that one sunspot group.
Yeah, that was in November, right?
It was, yeah. Just kept
Came
on.
around late in October.
Yeah, I remember seeing all the alerts and driving home from work, and I looked to the north and there was nothing. And then I turned round and looked south, and it was
Yeah.
gone completely past.
Right, can you, thank you. Right, this is going to show how this all sort of happens and why.
finger of doom.
Here we go. Okay, so here we have your sunspot. Somewhere here. Oh, I've lost it. There we go.
Oh, yeah.
That's the coronal mass ejection, and there's all that super cheap heated plasma. It's come up, it's hit the Van Allen belts, it's caused a bow wave, and that then reconnects, comes back to the Earth, and all that charged plasma has ended up going to the poles, and that's what causes the aurora. Yeah, if you want.
I can't see it. Oh, it's
Forward,
Hang on,
forward.
I'll go.
forward.
There you go.
I couldn't see the pad.
Right, there you go. So, as I say, it's going to come out.
Quite a nice animation.
It is.
That's really good. I've never seen this one
really
before.
explains it quite well.
Yeah, that's a good
And there it comes, and phew, all that
Charged
stuff.
particles, yeah.
Yeah.
shows reconnection very nicely.
Yeah.
So, and those are the sorts of effects you can get.
Yeah.
Okay, so we've gone through the sort of a quick summary of the life of the sun and the sorts of things that happen, and it's now reached its senior age, and this is actually Eta Carina, which they're watching because they know that at some point in the not too distant future, but saying that, not too distant future in the life of a star could be anything from 5 minutes to a century.
Yeah.
Although I think that's unlikely, I think it would be a lot sooner than that. So it's throwing off all its outer materials, and it's spreading out, and it's moving at some phenomenal rate, and it's thousands of miles an hour this is kicking this stuff out. So the central star is in the middle there, and it's throwing all this stuff off. So it's getting ready to go bang. And we all know that that's the Crab Nebula, and at some point it went bang, and that's spreading out, and it's still spreading out. You can't see it even through a telescope because it's so diverse now that your eyes just cannot pick it up. I mean, you haven't got sensitive eyes, but if you've got the right sort of equipment and you can take photographs of it, you will get it. You won't get it in colours like that, unfortunately. That's a Hubble shot. So of course you get all the different types of planetary nebula which are produced by a star going bang but not forming a black hole. And of course when it goes bang, it sends off a wind or a gravity wave that goes out, spreads out, hits these columns, and the whole cycle starts again. So that's really, in a nutshell, about the life of a star. Especially our sun, which hasn't quite got to that stage yet. Thank goodness. Okay, so having given you some of the sort of physical stuff and the effects, I'm now going to go on to observing. As was mentioned to start with, I'm not a professional, I'm an amateur, just a keen observer, because one of the people came along to, it was actually Lynn, who came to the York Society and was raving about solar observing, and I thought, okay, I'll have a look, I can't see what all the fuss is about. Well, wow, never looked back since. And I actually, these are the two main satellites at the moment, and there's others going up to observe the sun. And I cross-reference with these on a fairly regular basis. This is a warning I put up for everybody, and it is absolutely essential that you must be so careful. Right, so the safest way of projecting is using two pieces of paper. You can use binoculars, but you have to, again, be extremely careful. A safe way, if you've got children, is to have a light box on the end, so that there's no way a child, or an adult for that matter, can actually say, oh, look, that's my setup. There. So I have a I've got a cassegrain there with a solid glass filter on it. I've got a refractor which I do my projection on, and I have a little PST. And we have these circles so that you can well, I made these up, but using it from details from the BAA site, and you can look through and you can chart whether it's going, which part of the sun it is, whether there's prominences there, because I quite often use one and I use it for doing different things. So I will do a projection, I will do a visual observation, and I'll also look to see if there's any prominences. When I really started doing this, I decided, well, okay, I'm only keen sort of amateur doing this, but there must be something I can do with this data. And I found out that the World Data Centre in Brussels actually wanted all this data. And at that stage, I was the only person in the UK reporting. I was actually doing real science, contributing to the overall scheme of things. You don't have to be an expert, you don't have to be a professional, but if you're doing something on a regular basis and you are getting results, please do something with them. Don't just let them sit in cupboards somewhere and, for your records. Let the science communities have it as well, because I was the only person in the UK. Lots of people around the world were doing it, but we were all doing it at different times, and in some cases we were getting different results because of the sort of dynamics of the sun. Now I report to the BAA via Lynn, who reports not only to the BAA as records, but also to the World Data Centre, collating all the information from everybody that contributes. So it's ongoing, and we're contributing to the world of science. We're doing real science, and as an amateur with no qualifications in the subject, it's actually a feeling of doing something good. So that's my bit. Okay, so the other thing we get is what they call the Stonyhurst. So you saw that where I was doing the projection, and using that and looking at this and working out the degrees using the BAA handbook, I can have it positioned in the right angle so I can see where those sunspots are, whether it's north or south, and at what latitude, etc. But not only that, but these squares will define a certain size. So if I'm looking at what I think might be a sunspot group and I can compare it against that, I can actually say, well, actually that's one group, or it might be 3 groups, or however many, because of the distance between them, whether they are all connected. So I might have 2 or 3 of those squares connected with one group, or I might have one, say, there, and one there, and that would then be 2 groups. So that's another way of defining the information. Now this is what I regularly do. I'm no good at drawing, but from my point of view, I know that that was 2 groups, and I could count out the spots within it. Now, I've not found anybody who can explain why we do it this way, but you take the active region, which in this case, it was actually one group, but it was the way I'd drawn it. And I'd counted the sunspots within it, which was 6. But you then times it by 10, and nobody can tell me why. But that's the standard, worldwide standard that you do. So you have your active region and your sunspots, and then you times it by 10. And of course you record the date, the time, and what the scene is. And of course all the time is always universal time and not British summer time. So, as I say, I report to the BAA, and Lynn will produce a newsletter that goes out to all members who contribute, and she's got quite a lot of people, not just in the UK but around the world. And she will sometimes, she puts in pictures and drawing, people that have submitted drawings or whatever, so that other people can see what's going on. So again, it's still being, stuff is still being recorded, it's still there, and it's being used. This is the sun today. I did this on the way up on the train. I was hoping there might be something on there to make it of interest. We've had 8 days in a row without anything on there. And there are some prominences there, and I actually had a look on Tuesday. It was the only day that I could get to do it this week when it wasn't windy. And there were a couple of little tiny prominences there and around there as well, but they were so tiny, and I've only got a small PST, I haven't got a big telescope, so it's much harder to see if there's any others there. But again, I will record that on one of those discs so that I can see, and I can actually report that there was a prominence there. It might have been a big one, or it might just have been a little one, or it could have been a widespread one. So there's all those sorts of things. I can visually see them, but I just can't draw them terribly well. These are very useful websites that I use. I find that one excellent because it not only has what I look at the sky overnight. I haven't got a modern phone, so I haven't got apps and things like that. I haven't got an iPad. I have to use old-fashioned or older methods. But not only does it tell me what the sky is like, so I can pull up an active sky to see how it's, where the things are and where the planets are, if there are any. It will show me about satellites. It will show me all sorts of things, whether there's comets and things of that nature. So it's a very worthwhile. If I'm going on holiday, I can actually put in the details, and I can. So if I'm going to Spain next year and I want to see what sort of sky I'm going to have down there, or whether I'm going to see satellites and things, I look at that, and it gives me all that information, which is excellent. So I'm halfway there doing it before I've even got there. These are the sites that I look at for space weather, aurora, solar dynamics, which is great. That's an American site, but it's still quite useful because it does give you quite a bit of information. There's quite a good little map on there which shows where the auroral rings are, and you can pull it up so you've got the Europe site as well. So that's actually quite a useful one. And you've got Heavens Above, which, as I say, is the one I use up there. Okay, I'm going to stop just briefly at this point and ask if anybody has any questions, because this is a video that really encompasses everything I've said about the sun, its dynamics, and I've watched this umpteen times and it still causes a shiver down my back. But we'll do that in a minute if that's okay. Has anybody got any questions? I can't guarantee I can answer perfectly because I'm getting all caught up here.
Hazel, can I ask you about your recording of prominences?
Yeah.
How do you orientate your disc so you know it's...
Usually I'm using the one disc. If I've done a projection,
Right.
I will look at that. Otherwise I just think, right, I've got, I think of the sun like a clock. So I think, right, okay, that one's about 4 o'clock, or that one's at 10 o'clock, or whatever. And then I have to go refer to the handbook to find out whether it's north or south, and things like that. But I haven't done it in any real serious business with the prominences.
Yeah.
I just do that for my own interest.
Positioning it, and giving an accurate position
Yeah,
in relation to the tilt of the axis.
yeah.
Can I just make a suggestion? There's a piece of freeware software called Tilting Sun.
Mm-hmm.
That's what it's called. You can download it. If you have it on a laptop while you're observing, as an example,
Right.
you can put in your position on the Earth, and you can tell it whether you're observing directly through a star diagonal or projecting, in which case everything is inverted, left, right, etc. And the time of day exact, and it draws a diagram for you
Oh, how great.
which is correctly orientated according to your location and observing method, with the grid that you had on.
So,
Yes.
just remember, you said
Tilting Sun,
Tilting
hyphenated.
right, okay.
And it's
I'll have a look
freeware.
at that one. That's very useful.
There's the tables in the BAA would not give you that same information.
It does.
Tables will give you the information, but it gives you an immediate graphical view. If you've got it on a level table,
Yeah.
And
then
if
it's
you're,
correctly orientated, and you have it next to your projected diagram. You can
Right. You can
look
straight
straight across.
see
Yes.
the curvature.
But if you're projecting the sun onto a a card,
Yeah,
you set it up on an equatorial
Ah.
and let the sun trail across
Yeah.
you change your reticule.
Yeah.
Your
That's
circle.
that's where the Stonyhurst disc comes in.
Yes, yes, and then after that you stick the Stonyhurst down.
Yeah.
So it's just a matter of getting the sun to trail across it. You get north, south, east and west position.
Right.
Then when you've got that, you stick the Stonyhurst on. Well, in fact, you work from the BAA handbook
Mm.
and measure the degrees of tilt. Then you stick the Stonyhurst disc on from the plus or minus up to 7 degrees. And then you find where your position of your sun is, of your spot is.
But if anybody has number dyslexia like I have, it's very difficult using the handbooks, so that actually might be,
Right.
the tilting sun might be a brilliant aid for me.
Can't do good.
It's,
There's always an up.
yeah, there's always.
Because you're not projecting the prominences, so looking at them. I wonder how you'd orientate.
Well, I
Position.
haven't, that's the thing. I just, at the moment, because I don't do it enough and because I haven't got the facilities to be able to decide whether it's north, south, etc., I just work on the fact that I'm looking through my PST, I'm looking at it like a face of a clock, and I draw it to that.
You could use a cross here in the eyepiece.
Yes,
And
you
an
could.
equatorial head.
Yeah,
Let it drift across the
Yeah.
crosshair, and you'd be pretty well orientated, having to allow for the tilt of
Yeah.
the sun. But yeah, you could do it that way.
That's another option.
Interesting.
Anybody else?
You mentioned at one time that you were the only solar observer from Britain. Are there others now? Have you encouraged more?
I don't know, because due to ill health and various other things, I wasn't able to do it for quite a long time, and then Lynn got involved, so I just do it through there, so I don't know now. And they've changed their website and various other things now. I might at some point do it, but it then becomes complicated because I don't want to duplicate stuff that I'm giving to Lynn if I'm giving it to them. Otherwise it slews things. So, but if you look up World Ghost Centre for Solar Observing, you might be able to find out. I can't remember what the full term is now.
I was just wondering if you'd set a good example to other people.
Yeah, as I say, I used to do it, but I don't now. So, but I will look that up before I give this. I've given this at Easingwold in York next week, week after. So I'll think about that and get that done. So thank you for that point. Anybody else? Okay, in that case, I'm going to set this video going. It lasts for 3.5, 4 minutes. Might need to turn the volume down. During one of the BAA events, we actually had a lady come give a talk who worked for the Solar Dynamic Laboratory, and she had this video and very kindly let me have a copy of it. And it's just absolutely amazing. Whoever choreographed this deserves a medal. can't hold the sun.
I was actually going to ask, could we see that video again?
You may indeed. I just, if I'm feeling really down in the dumps and it's a really grey day, I put that on and it just lifts.
It's amazing. It's quite... I think what's amazing is that you look up every day and you see this big plain thing in the sky. You don't realise how much is going on.
Exactly.
It's just
Yeah.
incredible amount of stuff.
Thank
Thank you very much.
Thank you.
Any other comments or?
Yeah, can I just say that much of that, the video you showed at the end, the members will have seen, because a couple of years ago I did a thing called Our Amazing Sun, which showed the different things on it, and I used that at the end. That was mainly aimed for the younger members or younger people. I'm now working on one now for the adults. We did basically the exact thing, and I'm using that. I was going to use that on the end, but I don't think I'll bother because it's been seen now, you know.
That is just remarkable though. I mean, I agree with Dave because it's just sometimes hard to remember that that's our star and the incredible power of this thing that is in our sky. You know.
Well, that's why I just like to finish with that, because it really does encompass the entirety of how dynamic and how incredibly powerful it is. Wow. Gosh.
I'm wondering about the position we're in for the solar cycle at the moment. I'm worrying about the fact it's pretty low and the aurora are growing. Well, not quite growing yet, but aurora low. But what I'm thinking about is this. Previous to the last solar minimum, we would see different cycle spots starting at minimum. We'd see new spots starting at higher latitudes, 35 degrees. And often, in fact, most occasions I remember going way back, there would be simultaneous old cycle spots and new cycle spots at the very bottom of the trough. But last time I never saw that. I saw that the spots seemed to fade out from the previous cycle, and then the new ones came in, but there was very much overlap.
Yeah. If you remember from the diagram I showed, which showed the peaks and the troughs and things and the cycles, and I think that we're in one of those lower cycles, so we might get 2 or 3 cycles which are fairly low, and you're not going to get the activity as some of the more active newer times.
It's actually quite interesting to see the crossover.
Yeah.
Which occurred a lot, which didn't occur last time, as it were.
Yeah.
It had occurred previously. My first aurora activity was about 58, 59, when the sunspots numbers were huge. I've seen it come down and down to this last one.
Yeah.
I was just going to say, like, your list of websites, I was wondering if you've come across Solar Ham before.
No, I haven't.
I think you'd like that. Basically, it just collates all the data from SDO and it gives you predictions for like aurora and it also kind of has comments about all the solar activity. So that's usually the first place I go to kind of see what the sun's up to.
Yeah, likewise.
And I can show you the
Yeah,
list of
I
websites.
appreciate that, yeah. The other site I used to use was the one for Aurora, based at Leicester, Lancaster. But they've ceased doing it now, unfortunately. They couldn't get the funding to continue doing so, which is a great loss, I think. So that's why I have to refer to Space Weather and pick it up from there. But of course, it being an American site and all the rest of it, it's geared up for the other